All right, so 9.1, roots and radicals, is the start of Unit 6. So we're going to start talking about what the vocabulary is for this unit. So first talking about a power. So the power we've been working with before, it's your exponent, right? So a to the n equals a to the nth power, right? So it's raised to the nth power. Then a is the nth root of b. So then it could be, when we are trying to solve for a, we would take the root of it. And so that's why it becomes the nth root. Excuse me. Written as a radical, that's when you have the root symbol. The number on the outside is your index. The number on the inside is called your radicand. And then your radical symbol, obviously, is the little check house, whatever you want to call it. Okay. So key things to acknowledge about odd indexes and even indexes. If you have an odd index, your radicand can be positive or negative. Can be positive or negative. And you're going to always have only one real solution. And so you only have one real solution. Okay? Even index, your radicand can only be positive. And because of this, we can have we will have two real solutions. And the reason for that is, remember, a negative times a negative is a positive. So the index tells us how many in a group you want to have. So our index tells us how many we want in a group. So here, and the reason why we say group is because we're going to use our prime factorization example. So prime factorization is, we're going to break down 343. And so when we look at 343, what can it break down to? What multiplies to make 343? So as I look at this, I'm like, what can I multiply this by? Or what can I multiply to get 343? A good thing to think about are thinking about your multiplication table, what multiplication values end in a 3? Have a 3 in the ones place. And so when you're thinking about that, you can think about, well, 7 times 9 has a 3 in the end, so maybe this is divisible by 7. And so I have 7, and I'm double checking, and it's going to be 7 times 49. All right. 49 breaks down to 7 and 7. Because my index is 3, I'm looking for a group of 3. So for every group of 3 that I can make, I am going to take that value out. So I can make one group of 3, a group of 7. So the cube root of 343 is 7. Okay, so here we have the cube root of negative 64,000. So again, cube root of negative 64,000. Okay, so if we're looking for the cube root of negative 64,000, again, we're going to think about how can I decompose is what we're actually doing. Let's use some real math terms, huh? How can I decompose this value to see what the possible cube root is? Well, if you're thinking, I have this value, and if you want to start small, you can always start with 2. If I divide this by 2, I'm going to end up with 32 thousandths, right? Okay, well, what if I divide by 2 again? If I divide 32 thousandths by 2 again, what do I end up with? 16. If I divide by 2 again, what do I end up with? 800. If I divide by 2 again, what do I end up with? 4. I was at part. We end up with 400. If I divide by 2 again, I end up with 200. And if I divide this again by 2, I end up with 100. And if I divide this by 2, I end up with 45. So as you can see, I can keep dividing and dividing and dividing. What happens with this one when I'm dividing by 2? It's a decimal. So it's going to keep going and going and going. And so this doesn't necessarily help us in this process to try to find the prime factorization of it. We kind of want to think of 64 as a whole number and go from there. So see what happens if we kept dividing a decimal in half. I can keep dividing this in half. And so here I can divide this by 2, and I'm going to end up with 25 hundredths. Okay, and now I know I'm at 25 hundredths. 25 hundredths is 2 sorry. So if I kept going, this would be 0.05, 0.05. And it would just keep going and going and going. And it's like, well, I'm not getting anywhere. Well, that's because we're not going to think about it as a decimal. We're going to think about it as 64. And as 64, this becomes, sorry, so it's in my eye, 8, 2, 4, 2 and 4. Primes right there. And 4 becomes 2 and 2, 2 and 2, right? So here, if this was the cube root of 64, I would have, let's see, here is one pair of 3s, a group of 3s, and then here is another group of 3s. And so for every group of 3, they get to go out on a group date. So there's one group of 2s getting in a car, and there's another group of 2s, and so I multiply those and I get 4. Well, 4 cannot be the cube root of 64 thousandths. So the cube root of 64,000 has a 4 in it, but you got to remember your multiplication of decimal rules. And in order for this to work, I have to think about 4 times 4 times 4, right? And if I have 4 times 4 times 4, if I need to have 3 decimal places, that means that each one of these would need to represent a decimal place. So the cube root of negative 64 thousandths would be 1 negative and 2 4 tenths. Not 4, but 4 tenths. Negative 4 tenths, like that. Okay, I hope that helps. Next here, when you're taking the root of a fraction, taking the root of a fraction means that you're taking the root of the numerator and the root of the denominator. The fourth root of 1 is super easy. It is 1. Now I have 625. Well, 625 can become 25 and 25. And 25 and 25 becomes 5 and 5. So from there, I have one group of 4. Because my index is 4, I'm trying to see how many groups can I make. I can make one group of 4 of 5s. And so the fourth root of 625 is 5. My answer is 1/5. Okay. Here, I have the square root of negative 25. When there is no index, your automatic index is 2. So you're taking the square root. Well, if we look at 2, well, 2 is an even index. And because it's an even index, I cannot have a negative. So I cannot have no negative radicals. And so because of this, my answer is no real solutions. Okay. Okay, and our previous unit, we wrote this as an imaginary, but we're just simply stating that there's no real solution. If you want to be fancy, you can write plus or minus 5i to show that it's imaginary along with this, but writing no real solution will suffice. All right, so this is our practice that goes along with this. So I would like for you to pause and try these 6 problems. All right, thank you for pausing and trying. Let's check and see how you did. Here, no index means that it's the square root. So the square root of 169, you should have gotten plus or minus 13. Or the cube root of 729, you should have gotten 9. But I wanted to model another method with you besides the prime factorization tree. It's, I guess, called the reverse ladder, or yeah. So start here. You look at a number. I'm like, oh, it ends in 9. Maybe it's divisible by 3. So 3 evenly goes into 7 2 times with a remainder of 1. 3 goes into 12 4 times. 3 goes into 9 3 times. That's one step in the ladder. I'm like, okay, 3 again. 3 evenly divides into 2, 0. Evenly divides into 24, 8. 3 evenly divides into 3, 1. All right, I can do 3 again. Evenly divides into 8, 2, with a remainder of 2. That leaves me with 7. I can divide by 3 again. That gives me 9. I can divide by 3 again. And that gives me 3. So with the ladder, if I look, I have 1, 2 groups of 3. And because there's 2 groups of 3, 3 times 3 equals 9. Again, for this one, hopefully you remembered that you look at it as a whole, and 16 breaks down to be 4, 4, 2, 2, 2, 2, 4, 4, what's going on with that? All right, but again, it's not whole, it is 16 10,000ths, and so with that being said, it's not 2, it's 2/10. And it's not just 2/10, it's plus or minus 2/10 because it's an even index. On number 4, cube root, it's okay to be a negative because it's an odd index. Your index is odd. So I'm going to go ahead and pull that negative out, and I'm taking the cube root of 1 over the cube root of 8, which should have equaled negative 1/2. And then here we have the square root of 4 divided by 121. Again, square root because there's no number there. So we have the square root of 4, square root of 121, which equals 2 over 11. And again, because it's an even index, it is plus or minus. So my solution is positive or negative. And then cube root. So we have the cube root of 125 divided by 125 divided by 216. I'm going to say, okay, I have 125. Well, 125 is divisible by 5. That leaves me with 2 and 5. Divisible by 5 leaves me with 5. So I know that the cube root of my numerator has to be 5, is 5, not has to be. And then 216, I see 16, so I think, well, let me try a 4. So 2, 5, 1, 4, and I have 54. I'm like, okay, well, 54. I'm going to try 4 again. And if I try 4, it doesn't work, so I'm going to go ahead and say, okay, let me try 2. So I'm going to try 2, and that gives me 2, 1, 7. Right, okay. So now I'm at 27, and I'm going to try 3. So 3 gives me 9, and then 9, again, I can do 3. Now, the reason I showed you this ladder is that notice that 4 didn't really break down, and so it's not a prime here that I have, it's just 4. And so I can continue to break down 4 on its own, and when I do break down 4, I will see that it's 2 and 2 would be its primes, and so now I can clearly see that I have a grouping of 2's and a grouping of 3's. And so the cube root of 216 is 2 times 3, which is 6. So my answer is 5, 6. All right, here's some additional practice problems for you to do. If you feel like you need more practice, I want you to notice that with number 11, your index is 5, so be mindful of that. Here, again, square root, be mindful of that. Fourth root, that means that your result should be a plus and a negative. Again, fourth root should equal a plus and a negative. So give it a shot, see what you do, and check your work with the P. All right, part B. So part B is all about simplifying our radical expression with variables. So when we have a variable present, we need to remember a couple of things. If n is odd, then we're going to have a. If n is even, then we're going to focus on a has to be positive, right? That's what absolute value means. So if n is odd, a can be positive or negative. If n is even, our index, it only can be positive, okay? When you are finding the root of a variable, you are dividing by the power of the index. So for example, here I have 2. And so I'm looking at the square root of x to the 7th. And so I want to know how many times is 2 evenly divided into 7. So when I think about how many times is 2 evenly divided into 7, that is 3, right? And so what this is actually saying is that if I was to expand x to the 7th, I have x times x times x times x times x times x, one more x. How many groups of 2's can I make? Well, I can make 1, 2, 3. And because I can make 3 groups, I can take out x to the 3rd, and I'm left with 1x on the inside. And that's why you're looking to see how many times does it evenly divide. Well, 2 evenly divides into 7 3 times, and leaves me with 1 on the inside. Okay, so let's look at these with variables. So we have the cube root of 1,000 x to the 3rd y to the 9th. If we look at this and talk about it in expanded form, 1,000 is 10 times 10 times 10. X to the cube is x times x times x. Y to the 9th is y times y times y times y times y times y. Now y started looking a little xy. 8. Okay. So again, the index tells me on what kind of groupings I'm looking for. So here I have a group of 10, one group of 10. I have one group. Oh, I don't know why I used red, but I can make it easy to see. I have a group of x, and I have one, 2, 3 groups of y's. So now, for every group I have, they get to go out. So I have one group of 10, so they get to go out. I have one group of x, and I have 3 groups of y. So the cube root of this expression would be 10xy cubed. Okay, so here we have the fourth root of 256 g to the 8th divided by h to the 4th k to the 16th. And just like if their variables weren't there, you would still be taking the square root of the numerator and the denominator, the fourth root. So I'm looking for the fourth root of 256 g to the 8th over the fourth root of h to the 4th k to the 16th. So 256, if I wanted to think about 256, let's start with 4 and see what happens. So if I do 4, 4 evenly divides into 25 6 times and leaves me with the remainder of 1. 4 evenly divides into 16 4 times. I can break this down. 4 evenly divides into 6 1 time with a remainder of 2. Evenly divides into 24. And then I have 16 and 16. Notice this time, instead of breaking down by prime factorization, I started to notice that, maybe it's a little less of work for me. And I left it as 4s, and I ended up with a group of 4. And so, smaller tree, less work. I can see what's happening. So the fourth root here of 256 is 4. And I gotta remember, it's just not positive 4. It could be plus or minus 4. But because there are variables involved, I have to be mindful that it's not necessary to put it because it can wash up. But anyways, what is 8 divided by 4? Well, 8 divided by 4 is 2. What is 4 divided by 4? 1. What is 16 divided by 4? 4. Okay, so this would be my answer. And again, solution with absolute values. All right, so the square root, remember no index means square root, of this would be 6x. Remember x would be positive. Here, cube root of 216y cubed. 216 breaks down to be 4 and 54. 4 breaks down to be 2 and 2. 54 breaks down to be 6 and 9. 6 and 9 breaks down to 2 and 3. Boom, 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 bam, bam, bam. And now I'm going to look for my groups of 3s. And the reason why is because my index is 3. That's one group. Another group. So cube root 216 is 2 times 3. 3 divided by 3 is 1y. And so we end up with 6y as our answer. All right, again, square, because there's no number there. So the square root of 1 is super easy, 1. Square root of 100 is 10. And 2 divided by 2 is 1x. All right. So here are some additional practices. They do get a little more fun and exciting. So I would like for you to pause and try these, if you don't mind. Thank you for pausing and coming back and checking your answer. Here, you should have noticed that there's no index, so we're taking the square root, which means that 2's are out there, invisible 2's. And so how many times does 2 evenly divide into our power here? 20. And 20 divided by 2 is 10. So the square root is x to the 10. 8 divided by 2 is 4. So the square root is y to the 4. Okay? It does not change just because you have binomials. They are still being cubed into the 6th power. So you're still asking yourself, because this variable is still here, what is 3 divided by 3? And that's going to give me x plus 3. What is 6 divided by 3? And that's going to give me x minus 4 squared. Okay, pretty straightforward. My index is 5, so I'm going to divide each one of these by 5. And that gives me x squared, y third, and z to the 1. All right, let's do some of this. Please pause. Thank you for pausing and trying. So here, index is 3, and I have 27z cubed divided by z plus 12 to the 6th. So if I'm looking at 27z cubed, I can already kind of imagine what 27 is going to break down to, and 27 is 3 times 9. And so, as you can see, the cube root of 27 is 3, right? So that's going to give me 3. 3 divided by 3 is 1z. That's what that's going to give me. And 6 divided by 3 is going to leave me with z plus 12 squared. Okay? I have 2,401 x to the 12th, 2,401, and I'm going to think about how can I break that down. So if you're trying to think about numbers that multiply, you want to think about numbers that, if you look at your multiplication table, what numbers end in a 1? So if I have those, to end in a 1, we have 11 times 11, we have 3 times 7. So if I divide by 7, 24 divided by 7 gives me 3 with a remainder of 3. 30 divided by 7 gives me 4 with a remainder of 2. And 21 divided by 7 is 3. So now I'm at 343. I'm going to ask myself, think about a multiplication table, what numbers end in 3? I'm like, well, 7 again, let's try that. So 7 evenly divides into 34, almost 5 times, but not quite. It divides into there 4 times, and it leaves me with 6, and 7 evenly divides into 63, 9 times. And then 49 is 7 times 7. So the fourth root of 2,401 is 7. And 12 divided by 4 is 3. So my answer is x to the third. Here we have the cube root of 1,031 divided by x cubed. Again, I'm going to ask myself what numbers on my multiplication table end in a 1. And I have 7 and I have 11. I can try 7 and I'm looking at it, I don't see it working. But let's try 11. There is some repetition here. So if I try 11, 11 goes in 13 with 1, remainder of 2. 11 goes into 23 twice with remainder of 1. And 11 divided by 11 is 1. So this breaks down to be 11. I have a group of 3 11s. So the cube root of 1,331 is 11. And 3 divided by 3 is 1. My answer would be 11. All right. Here's some additional practices for you before you get started on your classwork. Please pause and try. Thank you for pausing. Let's check and see how you did. Hopefully we're getting pretty fast at this. So my index is 4. I'm going to divide each power by 4. And I end up with y minus 4 squared over z plus 9. Index is 3. Each power by 3. And I end up with a squared b squared over c. Here, index is 3, which is okay for me to have a negative. So my answer is going to be a negative 3 divided by 3 is x. 6 divided by 3 is a square. So negative xy squared.